Okay, as we finish chapter 10, one of the last things that we're going to talk about is writing and graphing equations for circles. Now, we've dealt with different properties of circles like tangents, secants, solving for chords, and solving for inscribed angles. And now we're actually going to look at the equations for a circle. Now, the standard equation of a circle, where the center is at the coordinates h comma k. Now this kind of looks weird, but you could write over it in your notes just x comma y, because it's just a location on the coordinate plane. It's at the coordinates hk, which would again be xy, and radius r. Now, with the center at hk and the radius a distance, let's write that down, distance. When you have that information, we can plug it into this equation. X minus h squared plus y minus k squared equals r squared. Now this looks really, really weird, but one of the reasons that they don't have the x's and the y's, one of the reasons they have the h and the k's, is because they would have x minus x plus y minus y equals r. And so they threw in an h and a k to kind of help you out with the center. But it's very simple. We just put in a value here, a value here, and a value here. One of the things, though, that you might have to do is solve for r. But that's coming a little bit later. Let's practice this. Just the fact of writing the equation for the circle. So we're looking for information. We're looking for the center and the radius, because those are the pieces of information we need in order to write the circle, or write the equation. So if I look over here to the side, I can see that my center is right here. Now, most of you know this as the origin. It's the intersection of the x and the y axis. It's at the coordinates 0, 0. And now I want to find the radius, and the radius is simply the distance from the center to the outside edge. Now, I could use this distance, I could use this distance, but one of the reasons that I want to use this one right here is because it follows the x-axis, and I can simply count the squares. 1, 2, 3. So with a radius of 3 and a center at 0, 0, I have all the information I need to write my equation. I'm going to start off with the blanket statement, or the blanket equation, x minus h squared, you should be writing this down, plus y minus k squared equals r squared. Now, one of the biggest mistakes that some students make is this idea that, oh, h is negative and k is negative. Well, that's not exactly true. The equation says x minus h. H is currently positive. If it was a negative, we would have x minus a negative, which would then turn it into x plus. Currently, h and k are positive values, and you'll see what I mean as we move through this section. But now what I want to do is I want to rewrite the exact same equation, but I want to put in my h and k. Now remember, h and k is just the exact same as x and y. So if I look over here at my center, the coordinates for my center, I identify my x as 0 and my y as 0, or again, you could do h and k, it doesn't matter, it's the same thing. So I'm going to put x minus, and instead of h, I'm going to find what h equals, which in this case is 0, squared, plus y minus k, which in this case, k is 0, squared, equals my radius, which is 3, squared. Now don't confuse this as the r squared is actually 3. It's r, which is 3, and then we're going to square that. Now we're going to take this one step further before we're actually done. I want to simplify this as best I can. Is there anything in here that I can simplify and actually make a little bit easier to understand? Well, yeah, one of the things I can do is I can actually solve these, and by solve them I mean simplify them. X minus 0 is just x, and then we have it squared. Y minus 0 is just y, and then we have it squared, and 3 squared is 9. The standard equation for this circle right here would be x squared plus y squared equals 9. Now, I hope that makes sense. One of the things that we're going to do at the end of this is teach you how to graph this on an actual calculator, how to take this problem and put it into y equals. But that's going to be more in a few minutes. Let's turn the page and go to the first example. They give me another problem identical to what I just had, except they move the center off of the origin, and then they actually do something different. They don't give me, they actually give me a point on the circle, and I'll explain why here in a second. But again, if they want me to write an equation, I need some information. I need the center, and I need the radius. Now, they give you a drawing here to help you identify what your center and your radius are. But let's say that they moved this, or they didn't actually give this to you. They just gave you the center and then a point on the circle. Well, what you would have to understand is the radius equals the distance from the center to the edge. In this case, the radius would be the distance from this point to this point. Hope that makes sense. Here's my center. Here's a point on the edge. It's actually on the circle, meaning it's on that outside ring. Again, if you do need a visual, you can simply look at this. Negative 5, 6 is on the edge of the circle, so by definition, the distance from here to here would be classified as the radius. But I want you to be able to do this without an actual visual, so we're going to move it over to the side for now. And I want you to think, what have we learned this year that can help me find the distance between 2 points? And the answer to that, I hope that you understand, or hope that you're identifying it, is the distance formula. And a lot of you don't like it, but it's something that you do have to be able to use. We know that the distance between 2 points equals the square root of x minus x squared plus y minus y squared. You'll also notice that this is very similar, it looks very similar anyways, to the equation of a circle, x minus the x coordinate squared plus y minus the y coordinate squared. The only difference is that we have a d here and not a r. Anyway, if I go through and I label my points, I'm going to make this x1, y1, and this one x2, y2. I'm going to go through and I'm going to input the values, as you can too, because this is not anything new. You should know how to do this. My problem should read negative 1 minus negative 5 squared plus 3 minus 6 squared. I'm going to go through and I'm going to simplify this, as you can too. Now I get the square root of 45, but I also know that the square root of 45, because we've already spent a full chapter on reducing radicals, is actually the square root of 9 times 5, and the square root of 9, I already know, is 3, so I actually get this reduced to 3 square root of 5. Now I know that that was very fast, and I know that we kind of assumed that you remember how to do this, but you can always go back to the Chapter 1 Reducing Radicals video, and you can review how to reduce radicals, because that's all this is. The distance formula is just that. It's a formula where you input values and you solve it down or simplify it down. And then the last step is just reducing this square root of 45. Okay, so now that I found my radius as 3 square root of 5, my center they already gave me at negative 1, 3. Now I'm actually ready to write my equation. I'm going to erase some of this information so that I've got some room to write it. Hopefully you're writing smaller than I am, that way you've got more space on your page. And so now I'm going to write the standard form of the equation, x minus h squared plus y minus k squared equals r squared. I'm going to go through and I'm going to input my values. I've actually already labeled my center as xy. I'm just going to very quickly write an h and a k above those so that you remember what is a h and what is k. So now I'm going to rewrite it using my values. X minus my h value, which is actually negative 1 squared, plus y minus my k value, which is 3 squared, equals my r squared. Now r here is 3 square root of 5, and it's still squared. Just like the last problem, I want to simplify this as best I can. And I know that x minus a negative 1 is actually x plus 1 squared. And that y minus 3 really can't be simplified any further squared. I can, however, simplify this. What happens when I square 3 times the square root of 5? Well, if you remember, we square both the 3 and the square root of 5. 3 squared is 9. The square root of 5 squared is 5. And as I multiply them together, I get 45. Now, this is the standard form of the equation for the circle that goes through negative 1, 3, negative 5, 6. Now, that can be kind of complicated, but really all you're doing is you're inputting values into a formula that's already created. The hardest part might be finding the information, like where is the center? Well, they gave that to me. Where is the radius, or what is the radius? What's the distance of the radius? You might have to solve that. One of the things that I really encourage you guys to do is graph it, because once you graph it, you can visually see what you might need to do. Some of you are just saying, Gentry, I just count over. And yeah, you can do that. Graphing it allows you to actually see, hey, what's a perpendicular distance? I could go straight up and find the radius. I could go straight right and find the radius. I could go straight left and find the radius. And that's totally fine. You just might find that sometimes you don't have the information, not even enough information. They just don't give you the option of graphing it. You might be on a time crunch, like on the final or on your ACTs, where you just very quickly need to just plug it into the distance formula, find the radius, take the center, put it in, bada bing, bada boom. The next example is actually asking us to graph the circle with the equation of. Now here we're going backwards. You'll remember that this problem right up here, the very first thing I did was I wanted to identify the center and the radius. So I'm actually going to do the exact same thing. I'm going to identify the center and the radius. Now, before I can identify the center, I know that it's h, k. If I go back, I can see that in my standard form right here. The center is at the coordinates hk. Remember, that's just the exact same as an xy. But I need to look, because this is my h, this is my k. Now remember, it's of the form x minus. So what I want to do is I want to look at this value right here. There should be an x minus, and then the very next preceding value is my h. Well, that's easy to identify because my h is just 4. The problem is, and you can see this here, let me erase this and use a separate or different color. Whoops, not highlight it, but erase it. You're going to notice in this problem, we have y, but we don't have a minus k. What I want to teach you to do is understand that there should be a minus there. So what I'm going to show you is kind of a cheat, is that we're going to put a little minus sign right there, a little baby one. And the reason we do that is this should be a negative 2. It should be of the form y minus a number. But here's the thing, my problem looks like this, y plus 2. The reason I put a little negative sign in there is because this. It was originally y minus. But if it's a negative 2, notice this. Y minus a negative 2 actually gets turned into y plus 2. So that k was originally a negative 2, but because we had y minus and it was already negative, it turned it into y plus. Hope that makes sense. If not, make sure that you ask questions about that the next day we meet in class. The last thing we want to do is identify our radius. Now I know back over here is my radius. The problem is that my radius, and we can notice this from up here where we wrote our standard form, my radius is squared. Well, this number doesn't have a square sign above it, so I'm assuming it's already been squared. Notice this. In order to find the radius, I'm actually going to need to solve for r in this problem. R squared equals 36. Remember, the r was originally squared, and now it equals 36. I need to do the opposite operation to both sides. The opposite of a square is a square root. Now this one worked out pretty simple to where r equals 6, but you will remember the previous problem when we did the distance formula, we got the square root of 45. And 45 is not a perfect square, which means that we needed to reduce it. We did reduce it, and we got 3 square root of 5. Here you got kind of lucky in that the radius was a perfect number, but that's not always the case. You might have to reduce radicals on this. So now that I have the information I need, I have my center, and I have my radius, I want to actually graph this. The center is at 4, negative 2, so I go 4, negative 2. And then my radius is 6. So I'm going to go 1, 2, 3, 4, 5, 6. And watch this. I'm going to go 6 units in every direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. About right here. 1, 2, 3. Oh no. I'm just going to guess. 4, 5, 6. Looks pretty good. Now here's the thing. I can't go 6 in this direction because it's on an angle and it wouldn't be the same as counting straight up, straight down, or straight sideways. I can't go 6 in any of the angled directions. So what I'm going to do is I'm just going to basically try and rough hand draw a circle here. I'm going to do it as best I can. And you know what? That's close enough. It doesn't have to be perfect. I'm not dealing with a compass here to where I can actually draw it out perfectly. A compass would make it easier, but you know what? I don't have one in my hand right now, so I can't use that. I'm just going to rough sketch it as best I can. But I also want to show you how you could graph this exact same equation. Let me rewrite it. That was from yesterday, for those of you who remember, or a couple sections ago. Just erase it real quick. We had our problem, x minus 4 squared plus y plus 2 squared equals 36. Now this is what I want you to watch. I can take this and I can move it into y equals and graph it on a graphing calculator. The way that I do that is I actually want to solve, or I want to FOIL this out and get x squared. I want to get rid of this squared problem. So what I'm going to do is I'm going to take x squared minus 8x plus 16. You can FOIL that and check my math. Plus y plus 2 squared equals 36. Now, if I'm going to solve for y, I need to get all of this by itself. And again, if you're not worried about how to graph this on a graphing calculator, you can just fast forward it through this. But those of you who are moving into Algebra 2 next year, you want to know how to graph these curved problems on a graphing calculator. So I'm going to subtract all of this at the same time. Notice when I subtract a negative 8x, I'm actually adding 8x. I'm going to subtract it from both sides. When I simplify it, I get y plus 2 squared equals negative x squared plus 8x. My 36 and negative 16 actually create 20 because they're like terms and I can combine them. Now watch this. I need to solve for y. Y currently is in these parentheses being squared. I need to get rid of that squared. So what I'm going to do is I'm going to do the square root to both sides. When I do that, I get y plus 2 equals the square root of, and we're not going to try and find the square root of this. We're just going to leave it as it is. Okay? And it looks really, really weird, and you might be a little bit confused, but just go with it. Now the last thing I need to do in order to get y by itself is move this positive 2. We move a positive 2 just by subtraction, very simply. Now notice this. I can't actually subtract the 2 from the 20 in this because the 20 is currently under the square root symbol. The negative 2 or minus 2 just has to go on the end. When I rewrite this, I get y equals the square root of negative x squared plus 8x plus 20. And then I want to make sure that I have parentheses around all of this, minus 2. Now that would be the equation to graph the circle. There's one more thing. Whenever you do a square root, like the square root of 9, you actually get two values. You get a positive and a negative 3. Most of the time we're dealing with distances to where the negative isn't even applicable, so we throw it out and we only have a positive 3. But understand that you actually do get two answers, a positive and a negative. Because of that, I have to graph both a positive and, let me rewrite it right below it, I have to graph both a positive and a negative form of this equation. And the reason for that is this, it's kind of cool. When you graph only a positive value for this equation, you'll only get half a circle. Your y-axis, or your graph, will only have one half of it. Maybe it's the top half, maybe it's the bottom half. That would be the positive half. When I graph the negative half as a separate equation, it actually goes through and it connects those dots to where now I have a perfect graph on my calculator. Looks pretty cool. We can practice that as you get into class, but you will do that in Algebra 2 and in Trig and in Pre-Calc, those of you who are taking those classes. We'll go back to our notes really quick. And that's actually all we have for this section, is the standard form of the equation, okay, knowing how to graph that, and knowing how to write the equation for it. Those two separate things. Not overly complicated, remembering that HK is the center and that R is your radius. Okay. All right, so that's it. That's actually it for this chapter. Remember that we are taking a quiz over this whole chapter, and let's take a look at your homework now.